It's a calculus summer with you. Okay, so this video is going to be an introduction to derivatives, and it's the summer I turned pretty inspired. Because The Summer I Turned Pretty is an amazing book series as well as an amazing TV show series, and it applies because derivatives really are the summer slope turned pretty. So what we're used to for slope is just the rise over run. So rise over run, which is equal to the change in y over the change in x, or delta y over delta x. And what we're used to here is the slope of the secant line. So the secant line is the slope between 2 points, right? And this, in notation that will become useful when we learn about the derivatives, it's going to be f of x plus h minus f of x over h. This is what we're used to. This is slope. This is the average rate of change. Now, where this changes, or slope becomes derivative, summer I turned pretty, is when we have something called the tangent line. Let's actually hop to a new page. Tangent line. Okay. Tangent line. This is going to be the instantaneous rate of change. So it's nothing brand new, it's just the slope at an instant, the slope at 1 point. So instead of it being between 2 as a secant line, it's going to look something like that, the slope at one given point. And so the reason why the whole f of x plus h equation is because when we're doing, derivatives, tangent line things, we're going to do the limit as h approaches 0, and then the same thing of f of x plus h minus f of x over h. And this is the limit definition of a derivative, which really is only important in the beginning of AP Calculus, and we'll move on to other techniques that are better and more efficient that you'll love so much more later on. But first, this is how we tackle derivatives. And then, I guess as a little sneak peek to something that will be really helpful throughout the rest of learning through derivatives is going to be the power rule, which, because we're doing the summer I turned pretty, it's not going to be the power rule, it's going to be the power flop. Yes, the power flop, because it wouldn't be derivatives without it. And the way it works, it's best explained through an example, so we'll just do it that way. So say we have the function 3x squared plus 5. Okay, so to find the derivative of this, which is going to be d dx, derivatives. So to find the derivative of 3x squared plus 5, for 3x, we're going to take the 3 times the 2. So the coefficient times the exponent, 6. Then we're going to take it 6x, and it's going to be the exponent minus 1. So it's just going to be 6x to the 1, essentially. And then all constants, the derivative of constants is 0. So really the derivative is just 6x here. So let's do another one. I remember this process took a little bit to just remember how to do this and just think okay, I multiply this by this, where are things going, what do I subtract, what do I add, and it can be a lot, but it will come in memorization. It really will, and then it will become really quick, and you'll be happy when you get to use the power rule, the power flop. So let's do another one. Let's take the derivative. Let's do something with higher power. Let's do 6x to the 4th minus 3x cubed minus 2x. Okay, So same concept here. We're going to multiply the 6 by the 4, the coefficient by the exponent. So that gives us 24. 24. Let's move this up a little bit. Okay, yes. 24, and then 24x, and then it's going to be the exponent minus 1. So 24x to the 3. Okay, great. We just took the derivative of that little thing. Okay, now we can move on. It's going to be minus, and then we do 3 times 3, which is 9. 9x, and then 3 from the exponent. 3 minus 1 is going to be 2. Okay, 9x squared, we got that one. Now we just have to handle the third and the last term. And so for this one, the exponent is, even though we don't see it, it's essentially 1 on that x. So we're going to do 2 times 1, 2. Okay, that stays the same. And then x is just going to be x to the 0 because we do 1 minus 1, the exponent minus 1. And x to the 0, anything to the 0 is just going to be 1. So 2x, the derivative of that is just 2. So then we end up with this lovely derivative right here. And that's the power flop.